So length of a polar curve. Recall the arc length for parametric. Okay, so let's write a recall. The arc length of a parametric curve. We came up with this expression. L was, since the variable or the parameter was t, let's go t1 to t2. It was one of the forms that we have was dx dt squared plus dy dt squared is the radicand, and we have the radical, and here we have d theta. So just for the sake of simplicity, a polar curve, we can use a parametric form, and we're going to say we replace t with theta. And the form now will be the integral from theta 1 to theta 2, the square root of dx d theta squared plus dy d theta squared, d theta. So this is the form, but I'm still here with x and y. So I do have expression for dx dy, dx d theta and dy d theta. So if replace, so use the substitution, use the expression for dx d theta and dy d theta. And I'm going to skip, I'm just going to give you the idea behind it. If you recall, dx d theta was dr d theta cosine theta minus r sine theta. This is something I showed you at the beginning of the class, right? When we did the tangent, we use the fact that the slope of the tangent dy dx is dy d theta over dx d theta, and we evaluated this, came up with the following expression. So dy d theta was dr d theta sine theta plus r cosine theta. Now, I'm not going to do it, but if you square and add, actually it's easy to do it, so I might as well do it. Let's square and add and see what happens on the next page. So page 3 here. Let's look at what is dx d theta squared plus dy d theta squared. Okay, it's a long expression, so let's write it down here. It will be, when you square it, it will be dr d theta squared times cosine squared, okay, minus 2 dr d theta r sine theta cosine theta plus r squared sine squared theta. This is dx d theta squared plus, now I'm working on dy d theta squared, dr d theta squared sine squared plus 2 dr d theta sine times cosine r sine cosine, right? And then finally plus r squared cosine squared. Okay, now this equals to, since we have addition, if you draw a line here and you add them up, you see that the middle terms, you have negative dr d theta r sine cosine, and then positive. So these two cancel out each other. And if you factor dr d theta squared, then you have cosine squared theta plus sine squared theta. Well, we know it's equals 1, right? And here, when you factor r squared, you have sine squared plus cosine squared. Oh, well, you know that this is equal to 1 as well. So the end result will be r squared. I'm going to change the order, right? R squared first plus dr d theta squared, like so. And this is the radicand. That's what goes into the square root. So now we have a simplified formula for the length of a curve. As theta changes from theta 1 to theta 2, then the length will be the square root of r squared plus dr d theta squared d theta. Okay? So what we did, I just proved a theorem. I proved the length of a polar curve theorem.